So hi everyone. This is Anteo from Kengo Kuma and Associates, Tokyo. Thank you, Alessandro, for having me. I'm one of the partners of the office, and I work between Asia and Europe. In Asia, I work mostly in Japan and Taiwan, and in Europe, I'm mostly working in Italy and Switzerland. So I'm very happy to see that some of the speakers today also have projects in those countries. I'm very looking forward to listening to the intervention. I heard that this webinar is also part of a Congress in Tatarstan. So I'm also happy to say that I'm supervising the Tamal theater project, and we are very happy with project development so far. So in our office, we use timber a lot, as you might know. And today I would like to show you some of our projects that are inspired by Japanese carpentry and Japanese joinery. And so Japanese joinery is famous because it doesn't rely much on steel and other material, but just on timber itself. And this might be because of a couple of reasons. It is said that metal was not widely available in Japan in the old times, so that the carpenter had to come up with systems that were relying on the wood itself. And one more reason is that maybe because of that, the Japanese carpenters were not trusting much metal. They were more trusting natural materials like wood. They were understanding it better, so it was difficult for them to trust metal with maybe a shorter lifespan, a different aging compared to timber. So most of the Japanese joinery is famous to just rely on timber, and then using timber, it allows to assemble and disassemble the architecture. So the first project I would like to show you is called Chidori, and it was done in Milan for the Fori Salon in 2007. It is a very small pavilion, but it's a self-supporting structure made of sticks. They are only 3 centimeter by 3 centimeter in section. And the inspiration from this joint came from the Chidori toys. There are toys that actually they also take from the Japanese carpenter system. So there are toys that assemble and disassemble small wood pieces to create small structures. And basically are made of 3 different sticks. They are joined together. And the peculiarity of this joint is that one of the sticks can rotate. So when the joints are assembled together, the final joint would rotate and interlock the whole joint together, and this will be stable. And the fact that this is repeated will stabilize the structure as well. So we made a bunch of these sticks, and we brought them to Italy, and they were assembled on site by students. And this is the resulting structure. So it's a self-supporting structure. These are a few images of the structure at night. And the same joint was then used for a different purpose in a more complex project. So in this case, we're talking about a building, not only an installation. So for the GC Museum, we collaborated with engineer Jun Sato, and he tested the Chidori joint until rupture and stated that we needed 60 millimeter by 60 millimeter, so double the size of the original joint. But this was still very, very thin and allow us to create this cloud-like structure that in this case had to support a roof. So it's not only self-supporting, but it had to carry load over it. And this is how the building looks. So the repetition of the same joint creates at the same time the structural system and the facade for this building. And again, it doesn't rely on much of nails, apart from some extension that are needed between one piece and another. And the fact that it was modular and based on a grid, it also helped for the exhibition inside. So artifacts or objects can be exhibited inside these cells that are formed by the structure. And this is the view from below. As I said, some sculpture can be inserted in these modules. And this is the view at night. So again, this project shows one of our concepts is to let's achieve beauty by repeating small and simple elements. I think this exemplify well this concept. And for Dazaifu Starbucks, we challenge even more this type of joint. So Dazaifu is a very famous temple just outside Fukuoka in Japan, southern Japan, and it's been there for more than 1,000 years, so it's a very old temple. And temples in Japan, they have this approach that is always lined with shops, and you can see the entrance gate of the temple on the far right. And we were asked to design one of these shops for Starbucks. In this case, we used the diagonal grid instead of a perpendicular one. So this was the challenge. So the elements are sitting on each other, and they are interlocking in one joint. 3 elements are interlocking in one joint and then are stacked together. And we choose a diagonal grid also because it's a very long and narrow plot. So this diagonal pattern helps to put into communication the 2 sides of the building. So it becomes a very long tunnel. And again, this is a self-supporting structure that is also the building structure, so it supports the roof. So adding one more level of, let's say, complexity to this system, we talk about building itself, and now it's not only about supporting itself and eventually a roof. In this case, it's actually supporting also a slab. So Sunny Hills building in Tokyo is located very close to our office. It's a shop and for a Taiwanese cake manufacturer. And then in this case, we needed to support not only the roof, not only itself, but also a slab in between. So the structure is more dense. This is the staircase inside. The staircase is also part of the structure with timber walls, and this is the rooftop. So we create a grid, and then this grid is fastened together by using a joint that, again, engineer Jun Sato that collaborated this project called Jigoku Gumi. In Japanese, it means it's the combination of the 2 words, Jigoku, that is hell, and Gumi is joint because it's a non-reversible joint. So the idea is that if you go to hell, you can't come back. So it's a joint that in the past was used a lot for furniture design. So elements that are not supposed to be taken apart very easily. And I think this is probably one of the first time that it was used for a building. So making this joint creates a very solid and stiff system. and this system is repeated, so in 2 layers on both sides to form a corner, and then diagonal elements are actually added, and these elements, they connect all the different layers, and they make all this system work together as one combined structure. So it was possible to hold a slab in between and also the roof on top by using this system. Again, not relying on metal elements. So these are viewed from inside. You can then understand why the facade becomes so three-dimensional, because all these sticks, they have to work together and collaborate in holding the building up. And these are a few views at night. So again, the concept here is to use one material, one element that is both the structure and the facade of the building. So and all the sticks are the same in terms of dimensions. So using the same element repeated many times creates a very complex structure, but made of a very simple, let's say, base unit. And last, I wanted to share with you a project that I was involved personally with, and it's called Botanical Pavilion. It was done in Melbourne. It was constructed in 2020, 2021 in collaboration with an artist called Jeff Nees. And this artist came to our office with the interesting story. He said that there were trees that had to be cut in the botanical garden in Melbourne, and he didn't want to dispose of those trees, as usually it's the procedure when a tree is cut, and he wanted to find a way to give them a second life because they were very beautiful and they had a lot of value. They were hundreds and hundreds of years old. So we decided to build a pavilion to showcase this different type of timber. And yeah, this is the final pavilion, but the original site was supposed to be inside of the Royal Botanical Garden, where the tree grew up and then died. And but we decided to we agree with the National Gallery of Victoria to do the pavilion instead of inside their museum for one of their events. So these are the different type of wood. We decided to color code the wood, so not use the botanical their botanical, let's say, definition, but to use their appearance and their color. And then we, after color coding them, we decided to make a gradient using the available wood, so from dark to light, to create a journey inside the pavilion. And again, it's relying on a very simple module. In this case, it's like a stick with some sort of feather. And these modules are joined together to form an H, and then stacked in one on top of the other, like a three-dimensional puzzle. And after they're stacked, they are fastened by an element in the opposite direction. That's also holding the structure in place, but also is used to showcase the timber inside. So we attach the pieces of the botanical timber inside. And then this module is repeated to form a structural arch. And then the arch is again repeated to form a semicircular, a little bit longer than a semicircular pavilion. The idea was to create a journey that could be could make people feel they are outside in the woods. So In Japanese, there's a word, komorebi, that means light filtering through the woods. So we wanted the visitor to experience that while walking in the pavilion. At the same time, showing the timber. You can see the timber is attached inside and creates this pattern and gradient with different colors. So you can see the light filtering through the pavilion, and then this color gradient that changes. That is, this is the darker part, and this is the lightest at the end. Again, we achieved structurally this by collaborating with another engineer in this case, Ejiri-san, from Ejiri Engineers, and they worked very hard to determine what was the best thickness for the wood to allow the formation of the arch at the same time to be able to carry the load of the pavilion itself. But it's one element that repeated makes both structure and skin. Thank you.
Anteo, thank you very much for your presentation. It was clear to the point and showcased the beauty of Kengo Kuma office work. I have actually a double question. Is Kengo Kuma office involved in the housing construction using wood? Because we know many projects for public facility from Kengo Kuma. We don't know so much about housing. And then, what do you think from the perspective of Kengo Kuma office could be the future for housing construction in wood, especially thinking about low density construction, not high rise?
Yes. So first, to answer your first question, yes, we do also housing, and timber is always our favorite material. So we've done some projects using timber, and we use timber to very different extents. Sometimes in only timber, that's the traditional way of doing houses, or sometimes we have hybrid solutions. So timber is part of the structure, and sometimes timber is the finishing material. So we have all degrees of let's say, we have various degrees of use of timber in our structure, and housing is definitely one typology that we also do with timber. And regarding the future developments of modular construction, it really depends on the country we are considering. But if by modular we assume prefabricated, I think that the challenges for the future are about sourcing the wood properly, and how much of those modular elements or prefabricated elements are reusable or recyclable. I think that's very important, and also how these products, how these systems are not, let's say, limiting solution both for the client and for the design. And in Japan, actually, it's a bit different than Europe. The construction industry relies a lot on timber for low-rise housing. That's the main material for single-family house. I think it's still by far the most used material. Is actually the cheapest, and so in that sense, we have some sort of advantage here. And there's some problems towards the future, because we have the population is shrinking and we have less and less carpenter. So in the recent and past years, the technology had helped a lot optimizing their time. So technology in pre-cutting and or prefabricating some timber elements had helped a lot. So they need only to assemble them on site. They don't need to work too much on the material or to shape them. And so in this case, I think it's a very successful way of introducing technology, let's say, in a very established and ancient practice, because it not only kept, but is also expanded